Assalamualaikum and good day to everyone. Today we continue our new topic on center of gravity and centroid. The objective of the lecture today are number 1, student should be able to describe the center of gravity, center of mass and centroid. Number 2, student should be able to describe the effect of position of the center of gravity with stability. Number 3, students should be able to determine the locations of center of gravity, center of mass and centroid of a body. Number 4, to determine the location of centroid for the composite body. Overall, the expected outcome of the lecture of today is students should be able to determine the location of centroid for the composite body. Now, what is the chapter outline of today? So, number 1, we're going to study what is the center of gravity. Number 2, stability. Number 3, centroid of body. And the last one, centroid of the composite body. Then, we can continue to the problem. Okay, now, what is the center of gravity? So, normally, center of gravity is present by the point G. Okay, look at this ball. Center of gravity is a point which locates the entire weight of the body to act. So, which is center of gravity is a balance point of the body. And then, a point that body can rotate freely in all direction. Okay, and then, the summation of all forces and moment at center of gravity is equal to 0. And then, the center of gravity for uniform body or homogeneous is located at the midpoint or its geometric center. And then the last one, center of gravity for not uniform body or distribution of mass is not constant. It located at the greater mass. So that is the what about the center of gravity. Now, take a look for the center of gravity for the regular shape. So, you can see here. So, normally, the centroid or center of an area of the shape is the point of the equilibrium. So, you can see this is the diamond shape, polygon, rectangle, circle, square, triangle, and also the cylinder. Next, this is the center of gravity for the irregular or non-uniform shape. So you can see that the center of gravity for the irregular shape can be found by suspending it from 2 points or more. Okay, so this is, you can see the point where is the weight is acting. So you can play around. So this activity you can have, you can cut off a card. Okay, you cut off a card, you make a few holes and then you use string to hang a paper. Then you make a vertical line. You make a vertical line, then you can see. Okay, the line of action must pass through the center of gravity of the particular shape. So this one is for the irregular or non-uniform shape. Okay, next you can see also what shape is this? So this is the L shape. So this figure shows that the center of gravity is not necessarily within the body of the shape, but it can be outside. So you can see here, okay, so this is the center of gravity. So this is the center of gravity. So normally, so the intersection of all plumb lines is the center of gravity. Alright, next, what is the center of mass? So, based on this figure, you can say that center of mass is a point which the entire weight of the body is concentrated. And then, it is also balance point of the body. So, which is, if the gravitational is constant, then the center of mass and center of gravity will be the same point. Right, next, what is the difference between the center of gravity and center of mass? So, you may refer to this figure. So, now we have two particles here, particle 1 and particle 2. So, particle 1 here, particle 2 here. So, center of mass, So center of mass is in the middle of the two masses. And then center of gravity, okay, mass 1 is greater. So the center of gravity is close to the mass 1. Okay, so that is the difference. Alright, next. Why is important to study the center of gravity? It is because you can see, based on this figure, center of gravity is useful to analyze human movement. And also, it is needed when applying Newton's third law motion. Whereas, if the center of gravity is located outside of the body, then it will cause a turning effect or a moment. So what will happen? So the body becomes unstable. Then, what is the stability? So based on this figure, you can see that, okay, this is how the stability, the body is instability, and then the next one when the body is unstable, and this one is the unstable. So stability is a point of equilibrium of the body at rest, and then the stability of the body is the ability to maintain its original position, which is it can be affected by center of gravity and base area. So a body is stable when its center of gravity vertically within its base support. So this is the base support. Okay. And then what is important of the stability? It is because principle of stability is applied when designing the shape. What kind of shape? Building, vehicles, furniture, apparatus, utensils, and daily tools. So you can see this figure shows that factors that affect the stability. So we have number 1 here, size of base. Number 2, horizontal distance. Number 3, height of gravity. Number 4, mass of body. And the last one, direction of base. So you can see here, look at this, the spot man. So they have to widen the base, kan? Widen the base and also bend the body to have lower of center of gravity. And also refer to these bikers and this one. So everyone need to bend, okay, to make a lower center of gravity. Why? Because we will need more stability. And then you can compare also this double-decker bus with this sport car. So which one is more stable? Definitely this car, this sport car, because it has lower center of gravity compare this double-decker bus. And also this one compare to this figure, okay, it also have the lower center of gravity. Look at this. Look at this. Why we need to sit? Why we need to sit down on this boat? Because we need to have lower center of gravity. Okay, so now this is a relationship between center of gravity and stability. So unstable, a body is unstable equilibrium. If body is slightly moved or tilted, so the center of gravity is rises. So gravity will pull it back to its original position. And then the next one, unstable. So this is unstable. A body is in unstable equilibrium. If body is slightly moved or tilted, the center of gravity is fall or lower down. So gravity will continue pull it downward. And then the next one, neutral. So a body is in neutral equilibrium. If a body is slightly moved or tilted, the center of gravity is rises or fall. And then the center of gravity remains level in horizontal plane. Alright, so how we calculate or how we locate the centroid of the body? Okay, how we determine the locations of the center of gravity. So you refer to this figure. So we have the locations of the center of gravity with respect to the X and Y and Z axis. So you can have here lah. So this is the X, this is the Y, and this is the Z. So we need to determine what is the centroid of this X, Y, and also Z. So based on this equation, we can integrate. So we represent here, this is X bar, Y bar, Z bar, means that centroid of the coordinate X, Y, and Z. So we need to integrate the X, dW, okay, divide by integrations of dW. So W means that is the weight. So it means that if you want to calculate the centroid of the weight, then we can use this integration. And then we also can use for the Y bar and Z bar. And for this equation, we can replace the W with a mass in the equation, the coordinate, if you want to get the center of mass. So if you want to get the center of mass, it will become the X bar is equal to integrate of the X dm. M refer to the masses and then divide by the dm. Similarly, the coordinate of the centroid for volume, area and length, you can replace, okay, with this weight by the volume, area and also the line. So very simple, right? Okay, next. Now we want to determine the centroid for the regular shape. So centroid is referred to the geometric center of the body, which is the centroid coincide with the center of mass or the center of gravity only if a body is homogeneous. Homogeneous means that density or specific weight is constant throughout the body. And then if a body has an axis of symmetry, then the centroid of body lies on that axis. So the centroid may not be located on the body. So you can see here, so this is the centroid for the rectangular area, and okay, and then this is the centroid for the triangular area, and this is centroid for the cylinder, and then this is for the quarter and semicircle. So this is the locations of the centroid. Now we want to determine number 1, centroid of rectangle. So you can refer to this rectangle. So this rectangle have B for the base. This is B for the base. And then we have H for the height. So how to measure the rectangle, the center of the rectangle? So number 1, the center of the rectangle is B over 2 and H over 2 are with respect to 90-degree corner. So let's say this is the 90-degree corner. So the locations of the centroid is B over 2. This is B and this is the B over 2. So this is the B over 2. And then H over 2 also from this corner. So this is the H over 2. So this is the centroid. And then number 2, X and Y are with respect to the origin. So where is the origin? So this is the origin. So we have here axis X, and then here we have axis Y. So X is equal to B over 2. So this is from the origin. So this is also B over 2. This is the locations of the centroid. And then Y, so this Y from this origin to this one. This is also H over 2. So this is how we can measure the centroid for the rectangle. And then number 3 is the area. So area is equal to B times H. So B times H is the area for the rectangle. Right, next, number 2, centroid of the triangle. So this is the centroid of the triangle. From this is also B is for the base, and then H for the height, for the H. Alright. Okay, number 1, the centroid of the triangle is B over 3 and H over 3 with respect to the 90-degree corner. So this is the 90-degree corner. So 90-degree corner, B over 3 is here, and then H over 3 is here. So this is the centroid. And then number 2, X and Y are with respect to the origin. So when with respect to the origin, this is the origin. So from here, So from here we have x. So x is the distance from the origin to here. This is the centroid. So here we have the total is b, and then the distance here is b minus b over 3. Okay, the next one, y. So y is from here, is also h over 3. Similar lah. Right. And then what is the area? Number 3. So the area of the rectangle, the area of triangle is half times b times h. So you must remember. Okay, next, centroid for the circles. So now we have centroid. So number 1, centroid of the circle, x and y are with respect to the origin. So x is equal to r, y is equal to r. So this is the origin. So here from this origin to the centroid is r. And also from this origin to the centroid of y is equal to r. And then this is the centroid of circle. And also C means that the center of the circle. Okay, and then for the area is equal to pi r squared. Okay, next, number 4, centroid of the semicircle. So you can see here, this is the origin and this is the center of circle. So now this is the semicircle. So now how we going to locate the center of semicircle? It is number 1, 4r over 3 pi. 3 pi is with respect center of semicircle. So where is the center of semicircle? This is the center of semicircle. So from here to centroid is 4r over 3 pi. And then number 2, x and y are with respect to origin. So now when we respect to the origin, so we want to locate the centroid of the semicircle is from here lah. This is from the origin is here is r. Okay, and then from the origin to the centroid is 4r divided by 3 pi. Okay, and then the third one is area. Area is pi r squared divided by 2. Okay, next, number 5, centroid of the quarter circle. So this is the quarter circle. So don't forget, this is the center. Center of circle. So from the center of circle, you can measure number 1, 4r divided by 3 pi is with respect center of quarter circle. So from here, this is the centroid. 4r over 3 pi. Okay, and then number 2, x and y are with respect to origin. So from the origin here, how to locate the centroid is x. X here is r, right? So this is the r and minus this distance. So from this origin to the centroid is equal that x is equal to r minus 4r over 3 pi. And then y. So this is from origin go to the centroid. So this one similar, r minus 4r over 3 pi. So because this is the r, right? So this is the r minus this one. So we can get here this one. Okay, so this is how we can measure the centroid for the regular shape. Alright, so now we can see the example 6.1. Now we want to determine the centroid of the shaded area. Okay, so this is the shaded area. Now, step 1, we need to identify how many shapes for center of the shaded area. So this shaded area is formed from the shape 1 is square. Square minus quarter circle. So we can analyze what is the centroid of the square and what is the centroid for the quarter circle. Okay, next, number 1. Shape number 1. Shape number 1 is square, right? So now we need to measure what is the centroid. So we have been given that B is equal to 300 and then H is equal also to 300 mm. So number 1, with respect to this corner, centroid is B/2 and H/2 from this corner. So that's mean that, and also from the origin also we can have that B/2 and H/2, right, from here, because this is square. Okay, from this here. So we can have that x1 is equal to B/2 is 300 divided by 2 is 100 mm. And also y1 is H/2, which is 300 divided by 2, which is 150. So the area is B times H. So B times H, 300 mm times 300 mm is equal to 90,000 millimeter square. And then this is the shape number 1. Next, shape number 2 is the quarter circle. Now we need to measure what is this centroid. Okay, so we can have here center. So this is the center of circle. So this center of circle. So we can measure the center from the center of circle to the centroid is 4r/3 pi. So here x2 is 4r/3 pi. So we can have here r is 300. R is 300. So 4 times 300 divided by 35 is equal to 127.32 mm. And then y2, so this is the y2. Okay, y2 is r minus 4r/3 pi. So we can get here 172.68. And then the last one, area 2. So area 2 is pi r square divided by 4. So r is 300. So you can calculate. So this is the answer. Next, you can tabulate into this table. So this table consists of the elements. So we have element 1 here. And then we have element 2. Then you must tabulate the centroid of x and centroid of y. So this is the x1, 150, y1, 150. And then this is the area. And then you need to multiply the area with the x and the area with the y. And then you locate here. So this is, you locate here. And then you substitute the element 2. So element 2 is the quarter circle here. So you have x2, y2 and also the area. Okay, so you must remember we need to minus. So we need to minus this square with the quarter circle. So you have the summation here. Summation for the area. Summation for the XA. Summation for the YA. So we want to determine the coordinate for the X bar is equal to summations of XA divided by summations of area. So here for the X bar is equal to 4.5 times 10 to the power of 6 divided by 19.31 10 to the power of 3. So we have the 233 millimeter. And then here we have for the Y bar is equal to summations of this divided by the summations of this area. Okay, so we can have that 67.32 mm. So you can locate lah. You can locate this is for the Y bar, and this is for the X bar. Okay, understand?